Okay, doing a little 3D printing here, and ran into a couple situations. I guess this is what we'll call them, situations. That we're going to look at for a second here, because I looked into it online, saw a whole lot of people with a whole lot of, I don't know, I guess we're going to call them answers. At least they were trying to help. But here's what I think. In these prints right here, you notice we got a gap here between the skin, and we're actually looking at the glass side. This is the side that was down towards the glass. So everything we're looking at, these little embosses right here, they were sitting on the glass. So everything else we're looking at was built on top of support. Okay. So what happened here was that the wall and the skin, which would have been the first skin, they didn't meet. If we go out here to the outside edge, though, they did. Whoops. Get back. So, yeah, that created some problems for me. And some prints in some areas are worse than others. Take this one, for instance. And this might be a 0.4 millimeter tip. I'm going to get into a little discussion further on down the road about these tips and volume. I've seen a bunch of guys talking about volume, so we're going to talk about volume too. As you can see, this one is a 0.6 millimeter tip. And you can see I still had the same problem. My slicer program's Cura, and I tend to believe that the problem is in the slicer program itself. And the reason that I tend to believe this, or even think that I know anything about it, is back when I was serving my apprenticeship, we got what they call a wire machine into our shop where I was working, back in the Lou Paul days, as we like to call them. And we were only the second wire machine in Jackson. Of all the tool and die shops, and there were quite a few of them back then, 8 or 10 probably. So back in that day, the only way that you could program these things was G-code. And anybody that doesn't know, on a CNC machine, something has to tell that printer head, and a 3D printer is nothing but a CNC machine, but something has to tell that head where to go. And what tells it where to go is the G-code. The G-code is the last line. That is what actually physically tells that motor where to go. So when you're programming in G-code, and we were just doing some really simple stuff compared to what we do with it nowadays, but you had to tell that thing, if you were doing this skin, and we didn't do no skins, we were doing all two-dimensional stuff, so it wasn't like a skin, but either way, that head is not being told to make it all the way to the wall. For some reason, and again, I believe this is in the code writing software itself, but for some reason that head is not being told to go all the way to the wall. And again, I believe it's in the calculations in the software itself. So what I noticed as I sat there and watched this thing run is that anytime that head came to a wall, if it did a Z retract and picked up, it connected to the wall without fail. If there was a Z retract, it was there. Anytime that it just turned around and headed back the other way, that's when we got this stuff right here. So somewhere within that code there is a flaw, and that stuff isn't being told to get there. Of these three parts, they're all different slices. It's very small changes to the actual bead itself, you know, on my width and on my height. There's some slight changes there. But other than that, and Filament brand, of course, because Cheap Charlie buys the cheapest stuff he can get his hands on. But other than that, these are three independent slices of the exact same initial program, an initial CAD drawing. So for some reason it tends to follow up in the same spots, but the degree that it has this problem changes. So I don't know, I'm no code guy. I could probably get in there if I really felt like I was bored and didn't have nothing to do. I could get in there and start weeding through this G code, and I could probably find these spots and correct them just by changing the numbers that are in there. But man, I ain't got that much ambition. Okay, so that's my thoughts and opinions on what's going on there, and we're going to move on to volume, I think, or something like that. Okay, onward and upward. Okay, now we're down in the 3D printer room, and I want to talk to all these engineering type guys. Personally, I'm a tool and die maker. Anybody that doesn't know what that is, engineering guy draws up all these blueprints and hands you them all. You know, he's got to give them to somebody. He's got all these things drawn up of this piece of equipment he wants made. He hands that to me. I'm the tool and die maker. I'm the guy that gets them blueprints and tasked with making it. So we're the guy that makes it happen. They come up with a theory, they hand that theory to us, we put it into practical application. So a lot of different engineers out there, everybody's got their specialty. But here's what I've discovered, okay? What I have here is some examples of different filaments, and all of these have been run through a 0.6 millimeter tip. All at the same flow rates, all at the same speeds, all that good stuff. And old Cheap Charlie will buy the cheapest filament he can get his hands on. So sometimes there's things you got to compensate for when you're operating like that. So this is what I've discovered. All of these, bear in mind, came out of a 0.6 millimeter tip. Got some good old-fashioned micrometers here. You know, we're getting down to the nitty-gritty. If we come down here and measure how thick this is, you can see that it's, one revolution would be 50, and then we're on the 30, 50, 60, 70, 80, 0.8 millimeters. And that's coming out of a 6 millimeter tip. So this plastic, for whatever reason, this PLA expands after it gets out of that tip. Here's a little different color, a little different spot. What do we get there? That one's also about the same, 0.8. Screw these things down all the way, that's 0. One revolution is 50, or 50, 60, 70, 80, and so on and so forth. Okay, let's check a couple other ones. And again, these all came out of a 6 millimeter tip, or a 0.6 tip. So we got this one here. That one's about 50, 60, 70, 22 and 50. And right here, attached to the same thing, I was changing from one roll to the next. So what did I say that one was? 50, 60, 70, 72. And this white one is 67. This is how much difference there is in these filaments. This one here, 70, or 0.7. I call it 70, it's just the way we talk in the trade. 0.75. This is the one that we saw upstairs, the green that we saw upstairs that was really bad looking, and I think I got a little carried away with my settings on this one. This one is measuring about 92 or 0.92. That's almost 1 millimeter. And that's coming out of a 0.6 millimeter tip. So when you guys start talking volumes with me, I can tell you, yeah, that's all and fine. But the problem I'm seeing is you're not checking that filament to see how thick it really is. Therefore, your volumes are based on your tip size, not your actual physical bead of plastic that's coming out of it. So if you want to do your volume calculations and tell me that I should be set here or should be set there, that's fine. But let me see you measure the filament first and make sure that your volume is based on an accurate number. Okay, now I got one more thing we're going to touch on, and it's a problem I had making some cones, and it took me a second to figure out why they wouldn't come out right, but I did get it figured out. All right. Okay, we're back upstairs. Let's take a look at these tops again. And the problem that I ran into was over here. This pink one's one of my prototypes. But I've got these cones, okay? As you can see, and we still had the problem with it not connecting with the wall, but you can see them cones are an absolute disaster. They're just a wreck. Take for instance, compared to the cones on this gold one. And here's that green one that had such thick filament that was almost a full millimeter, 0.9. Anyway, so these cones were a problem, and what them cones are for is right here in this other piece. It kind of locks the two pieces together a little bit. Pretty much just the cones set in there and they're kind of locked together. Holds them together a little bit. Okay, so man, I just was scratching my head trying to figure out what was wrong with them cones, and finally it dawned on me. You can't stick an end mill down in a slot if the end mill's bigger than the slot. That's what made me think of it. But now we'll get into what really happens on these 3D printers and your slicer program, well, Cura, and how it reacts to different situations. Okay, we're going to have to move over here to the old CAD. Okay, now we're over here on the CAD, and what we got is this right here is that cone. So this would be the one on the top part. This is the one that sticks out, not the one that's caved in. And originally I had this drawn on a 45-degree angle. It's not 45 degrees right here. It's actually 53, but anyways, so originally I had this point. This is where the glass was. This is where it all started. This purple oval represents the bead of the very first layer that's laid on the glass. It is 0.4 millimeters tall, and I believe I used 0.8 millimeters wide. Of course, you squash your first bead down to the glass pretty good, and then your next bead, this one is 6.3 or 0.63. I'm sorry, 0.63 on the height. No, I used 0.6. Let me check this. Yeah, I used 0.6. Okay, so anyway, irrelevant, all irrelevant. So what happened was, when Cura decided to slice this program for me, now we're going to switch this over so we can see more wireframe. So what Cura did, because my glass was down here, Cura generated this very first layer, this 0.4 millimeter tall layer. And I was working on this triangle right here, because I had it drawn so that it came right down to a point. When Cura recognized that that bead wasn't going to fit inside this little tiny triangle right here, it just opted not to print that bead, that very first layer. It also opted to not put any support there. So then when it generated the code for the second layer, layer number 2, or the 0.6 tall layer, again, it noticed that a lot of it wasn't going to fit inside that triangle. So again, Cura opted to just not print that layer. Also, no support. So by the time Cura decided that it could get the bead inside the area, back to them guys with their areas, volumes and so forth. We were on our third level. So at the third level, it decided to go ahead and print one. Well, of course, it didn't have anything underneath it for 2 levels. And then like the pink top that I showed over there where the cones look so horrible, that's why, because that first layer came down and hit the glass and just did all kinds of crazy stuff. So what I did to fix the problem was I redrew this, my bead, my very first layer. I moved the glass, I moved the whole part down so that the glass was right here. This is where my first layer was going to go down. Or my point 4, this purple one, that one. So then I knew that when Kira read this, it could see that it could get that entire bead laid down in there. And Kira, just like you've seen in the parts over there, it corrected the problem for me. I don't know on Kira if the second layer, if it jams 2 of them together like this, or if it only prints one of the 2, be it this one or this one. I don't know what it does with that. I didn't sit down and watch it to see. But by the time you get to the third layer, you see I kind of, and this is all on 54 degrees, and this is how I decided what angle to put it on. Was I drew a few in there and then threw a line across them and called it good. I probably could have brought this line down tangent with this one and got a little better results yet, but I went like this and it doesn't look too bad. So okay, if you ever run into a problem similar to that, that right there is how you cure it. Alrighty.